Hello, friends! Today we will be discussing one of my absolute favorite topics, the beauty of science. Science is unfortunately a relatively misunderstood field, but by better understanding what it is, we can better see its inherent beauty. So let's talk about it. What is science? Science is the pervasive effort to develop an increasingly accurate understanding of the world around us using observation and reasoning. Scientists attempt to be as objective as possible in the interpretation of the data and observations they have collected. Because scientists themselves are human, this is not always completely possible, though. But because science is a collective, collaborative endeavor subject to scrutiny, it is self-correcting. One person's results are verified by others, and if the results can be repeated, then the results are said to be supported. But if they cannot be repeated, they are rejected. A lot of times people look at science as a mechanism for proving things right or wrong, or squashing other people's ideas or creativity. But really, this cannot be actually further from the truth. And we are going to explore that today. Now, since this is a biology class, let's dive a little deeper into the specific facet of science, biology, exploring its beauty, creativity, and applicability in all things. Biology is the study of living things, also known as the science of life. Biology is a beautiful, living science, and just like the life that it studies, it is a growing science, and it grows each and every day. And something that is truly incredible about it, it inspires and in truth requires creativity. To be a true, successful scientist, you too must truly be a creative. You must be able to see the world around you and find intrigue and curiosity within it, ask creative questions, and develop creative ways to help answer those questions. But biology and science as a whole is no solo adventure. It both invites and requires collaboration, working never to prove anything, but rather to develop theories that can either be supported or refuted to help us all better understand the beauty and intricacies of life. So, how do we appropriately study these intricacies? Well, biology is always growing and expanding, but there are some things that we collectively call quote-unquote true, right? And while nothing is ever proven, we do use this jargon sometimes. So how did we get there? How did we come to the point where we try to say that all living things are made up of cells, or that blood is thicker than water? We got there through using something called the scientific method. The scientific method is how we learn new things. And while this term, the scientific method, sometimes gets a bad rap, in truth, it is part of what makes science so beautiful. And it really is one of the most misunderstood aspects of science as well. So let's talk about it. The scientific method helps us explore our own creativity and curiosity in a constructive way that helps us avoid bias and supports our efforts to further our knowledge of the world and life around us. Scientists, or as I like to call them, creatives with titles, are able to determine what principles are likely to be true from among the many ideas generated by themselves and others through the systematic process of observation and experimentation. If the proposed principles do not align with the results from our experimental observations, then those principles are rejected and deemed as untrue. So, what does this systematic process look like? Well, it all begins with an observation, looking at life and the world around us, and then from that observation, we can develop a research question in reference to what we are observing, what you see, sense, touch, taste, hear, and so on. We then develop hypotheses and predictions on what we believe to be the possible answer to our research question. But to help ensure that we are making grounded hypotheses, it's really important to always do at least a little bit of research first, right? Reading up on what has already been studied in relation to our research question and making sure that our hypotheses make sense. We then put our hypotheses to the test and develop studies or experiments, which, once carried out, we can then analyze the results of to see whether our hypothesis is supported or refuted. From there, we can draw conclusions from our original research question, and our conclusions can then feed into this beautiful cycle of knowledge growth. And this cycle continues, carried on by both us and others in a collective, collaborative effort to better understand the world around us. Now, as previously said, it is important to note that nothing is ever proven in science. We simply aim to either support or reject our hypotheses. This is because with every truth that we find, we cannot say for certain that it will always remain true, right? With every rule, there is an exception, and we can't predict the future. But we can support our hypotheses, and with enough support, we can begin to presume truths without directly proving it.